Intro to rate equations in 3 minutes. You can define the rate of reaction as the amount of product formed over time, or the amount of reactant used up over time. Or a more general way is to just say the change in concentration over time, or the change in concentration of a reactant or product per unit time. Units for the rate of a reaction are moles per dm cubed per second. Now, symbol commonly used in A-level chemistry are square brackets, which represent the concentration of a substance. Now, if you have a concentration against time graph and you want to work out the rate of reaction at a particular point, you need to work out the gradient at that particular point. So in other words, concentration over time, or change in y over change in x. If this is on the curved part of the graph, then you need to use a tangent. The term reaction order tells you how rate is affected by concentration in a reaction. There are different types of orders you can have in a reaction. The first is zero order. If a reaction is zero order and you double the reactant's concentration, then the rate does not change. It stays the same no matter what you do to the concentration. Mathematically, you can say rate is proportional to a to the power of 0 or 1, as anything to the power of 0 is always 1. For a first order reaction, if you double the concentration of the reactant, then the rate also doubles, which means they're both directly proportional, or we can say rate is proportional to a to the power of 1. For a second order reaction, if you double the concentration of the reactant, the rate quadruples. This is because rate is proportional to a squared. If you were to triple the concentration of the reactant, then the rate would times by 3 squared, which means it would times by 9. The concentration time graph for a zero order reaction is a straight line downwards. For first order is a curve downwards, and a second order is also a curve downwards. Rate concentration graph for a zero order reaction is a horizontal line. For a first order reaction is a straight line to the origin, and a second order reaction is a curve upwards. There are two methods to find out the order of a reaction experimentally. The first method is known as the half-life method, and this proves whether a reaction is first order or not first order. Definition of half-life is the time taken for the initial concentration of a reactant to half. So on a concentration time graph, work out the half-life by finding half of the initial concentration. Draw two lines to work out the time taken for the initial concentration to half. One line is a horizontal line up to the curve, and the other is a vertical line down to the x-axis. Repeat this again at a quarter of the initial concentration to find the second half-life. And if both half-lives are constant, then it means the reaction is first order with respect to that reactant. The second method to work out the order of a reaction is known as the initial rate method. To find the initial rate in a concentration time graph, you need to draw a tangent at time equals 0 and find its gradient. So let's say we wanted to find out the reaction order for the following equation. We would first carry out the reaction with the known initial concentrations and then use the above method to find the initial rate. We would then repeat this process again by changing the concentration of one reactant but keeping the other two the same, and then find the initial rate of that. We would then repeat this process so we have enough information to work out the orders of each reactant in the reaction. To find the reaction order of NO, we would compare experiment 1 and 2 because that's the one where NO is the only one changing. NO is doubling but rate is quadrupling, which tells us it's second order. For the reactant CO, we compare experiment 1 and 3, and CO is doubling but the rate is staying the same, which means that it's zero order with respect to CO. And finally for O2, we compare experiment 1 and 4, and O2 is doubling but rate is also staying the same, so it's zero order with respect to O2. This was obviously a very quick summary. For a longer, more detailed explanation of the topic, check out the link to the full lesson and subscribe to my channel.